Chapter 15, Part 2, we will talk about heat. Now, if you touch a hot stove, probably your hand will get burned. Why? Because the hot stove is hot. So energy will transfer or will enter your hand from the stove. If you touch ice, what will happen? What do you feel? You will feel cold. And the reason is your hand is warm. Ice is colder. So energy will transfer, will pass from your hand into the ice. So energy transfer will always be from warm to cool. This energy transfer from one object to another, because of the temperature difference between them, is called heat. Now, just to clarify things, matter objects, they don't contain heat. They have energy. So what is heat? Heat is the energy in a transfer. It is the energy in transit. It is the amount that's transferring from one object to the other. Once this heat transfers, complete the transfer, we don't call it heat anymore. It becomes part of the internal energy of the object. It becomes part of energy the object has. Now, when heat flows or transfer from one object to another, which is in contact with, the two objects are called in thermal contact. When the two objects in thermal contact, then heat will transfer from the warmer to the cooler. So, as we said, heat flows according to temperature difference. That is, and you remember what is temperature? It is the average molecular kinetic energy. So the temperature difference is how different is the average molecular kinetic energy between the two substances. Heat will never flow from cooler substance into a hotter substance. It is similar to water, for example. Water will never flow on its own uphill from below up. Same thing with heat. Heat will never flow by itself from cooler substance into another hotter substance. Now, when two objects are in thermal contact, heat will flow until both objects reach the same temperature. Once they have the same temperature, we say they are in thermal equilibrium. So thermal equilibrium means the two objects are having the same temperature and they are in thermal contact. No heat flows between them at that stage. Let's take an example. If you look at the picture on the left, you have a container here and there is water, let's say 1 liter of water, and we are using a flame to heat the water. Now, after some time, the temperature will rise. And let's say that the temperature is rising by 2 degrees Celsius. Now, the question is, if we add the same amount of heat, same heat, but to 2 liters of water, like here, what do you think the temperature will increase by what? By how much? Think about it. We are giving the same amount of heat to both amount of water, but the water on the right is twice the water on the left in amount. So the question is, how much will be the temperature difference in the right picture? The answer is temperature will rise by only 1 degree Celsius. Why? Well, because the 2 liters of water contains twice as many molecules as the 1 liter of water. And so heat will only give half as much energy in average to each molecule on the right compared to the left. So the temperature will only rise by 1 degree Celsius. Similarly, if you have two containers, one contains little amount of water and one more amount of water, and you are heating both, of course the temperature of the smaller amount of water will increase more than the one which contains more water. Heat is a quantity which has units. Now the most commonly used unit for heat is calorie, and I'm sure you heard about the term calorie with a small c, calorie. So what is calorie? Calorie is defined as the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. 1 gram of water is something like this. Look at this box, small box. It's only 1 centimeter length, 1 centimeter width, 1 centimeter height. So the volume is 1 centimeter cube. It's a very small box. If you put water in it, the amount of water will be 1 gram. So it's a very small amount of water. Now, if this water has some temperature and you want to raise it, to raise the temperature by 1 degree only, you have to give it some heat. How much heat you need? 1 calorie. So that's the meaning of 1 calorie. There's another unit which is called the kilocalorie. And you remember that kilo means 1,000. So a kilocalorie is 1,000 calories. And this quantity or this unit, it is the heat needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Now 1 kilogram of water, you can put it in 1 liter of volume. So this is a liter, and I'm sure you are all aware of the liter. So if I put water in 1 liter, the amount of water will be 1 kilogram. Now if this water has some temperature and you want to raise the temperature by 1 degree Celsius, how much calorie you will need? 1,000 small calories, or what we call the kilocalorie. Now, when dealing with food, companies, they like to write the amount of heat you can get from food using the unit of kilocalorie rather than the calorie. Sometimes it's confusing, what's written on packages, but be careful. Usually, if you are want to use the kilocalorie, we like to call it calorie with a capital C, written as capital C, to distinguish it from small calorie. So usually you have to be very careful about this. There is a small calorie and there's a capital C, calorie. So a calorie with a capital C means kilocalorie, 1,000 of small calories. Both of them, small calorie or a capital C calorie, are units of energy. Now, in general, in science, in the international system of units, we like to use different units, and these are the joules. You are familiar with those units, joules. Now, 1 small calorie equals to about 4.186 joules. Once we eat food, we get energy from food. For example, if you eat a peanut contains 10 capital calories, 10,000 small calories. For a physicist, it means that if you change this number into joules, you are eating or you are having about 41,860 joules of energy when you digest this amount of food. Question: which will raise the temperature more, if you add 1 small calorie of heat or 4.186 joules of heat? What do you think? Of course, the answer is the same, because they are the same quantity. We just express them in different units.